Okay, so now we're looking at question 1, section J, which obviously requires you to have done section H's and I first. And this is about what is the pH of a solution of mixing all of H and all of I. And what I've done on the screen to start off with is I've put some of the calculation parts to both of these sections of the worksheet. And I put them like this for a very good reason. So you can see solution H, we had 750 centimetres cubed, and we worked out how many moles of sodium hydroxide were in there, and it was 0.375 moles, which equated to 0.5 mole per decimetre cubed. Solution I was 250 centimetres cubed with 0.1 mole of hydrochloric acid in it, which equates to 0.4 mole per decimetre cubed. So what this question is about if we put all of this with all of this together, what is effectively the pH? And the way we need to really think about this is we need to think about what's actually happening when we mix hydrochloric acid and sodium hydroxide and alkali together. And the answer is, well, neutralisation is happening. The acid will be neutralised by the alkali, and the alkali will be neutralised by the acid. So what we're really saying is, if we put these two together, this sodium hydroxide is going to be neutralised by this acid. So let's just do that, okay? So adding some numbers together and doing some takeaways. What I've done here is, well, we've got 750 centimetres cubed and 250 centimetres cubed, so if we put them both together, we've got effectively 1000 centimetres cubed, or 1 decimetre cubed. So that's of importance, but we'll talk about that just now. Now, what's happened here is the acid, the 0.1 mole of the acid, is neutralised 0.1 part of the sodium hydroxide. So in effect, this is a takeaway sum. 0.375 moles has been neutralised, or 0.1 mole of it has been neutralised by the acid. So what we're effectively left with is 0.275 mole of sodium hydroxide. And this is where this 1000 comes in. 1000 centimetres cubed is 1 cubic decimetre. So what we've effectively got is we've got a sodium hydroxide solution which is 0.275 mole per decimetre cubed. If this number was different, what we would need to be doing is we would need to be just in this figure now into whatever the volume was, so it was moles per decimetre cubed. But as it stands, because this is 1000, these two numbers conveniently add up to 1000 centimetres cubed, 1 decimetre cubed. We have 0.275 mole of sodium hydroxide. The concentration in moles per decimetre cubed of sodium hydroxide is 0.275. And we're now in a position to work out the pH. And we do it like this. So here we are. We've got POH, so we've minus log of 0.275, which comes to 0.56. And to make it a little bit easier in terms of calculation, because this is 0.56, I've rounded it to 0.6. But of course, this is the POH, not pH. So what we now have to do to finish this calculation is to take this value away from 14 to give us our pH value. And we do that like this. So now we have the final pH of the solution. And let's remind ourselves what we've done. If we mix 750 centimetres cubed of the sodium hydroxide solution given to us in part H with 250 centimetres cubed of hydrochloric acid given us in part I, we get a pH of that solution in total being 13.4. And that's it, that's the answer to this question. Thanks.